Now, star charts tell us an awful lot of information besides just how bright stars are. Um, these constellations actually move across the sky, and I want to talk about how these constellations move, because what you see tonight at 6 p.m. Is not what you're going to see tomorrow night at 6 p.m. or at 7 p.m. It's going to change, and it changes because the whole heavens are in motion. So constellations tend to move across the sky from the east to the west, just like the sun rises and sets. That it's not that the constellations move. The constellations are relatively fixed. We pretend they're fixed, but they're so far away they look like they're not moving. And remember, it is the Earth. We're the ones who are rotating underneath the stars that actually gives us that impression that the stars are actually moving. And they're going to actually move a little bit every night. And later, I'm going to ask you to watch this video. Now, because this Earth is moving, for tonight, we're going to see a certain, next to the sun, we're going to see these constellations. If we move a little further this way, it's not a big difference, but in the span of multiple days, we're going to see slightly different constellations, and that will change as we orbit our star. Every star is going to rise about 4 minutes earlier every night. Now put a little star by that. That's something I'd like to have you know. So that, for example, if you looked at the constellation on January 23rd and you looked at him on January 24th, he's going to be a little bit earlier, ahead of maybe sunset, because, or did I say that funny? I did say that funny. But 4 minutes earlier every single night. So in 2 weeks, 4 minutes times 12 days or 14 days, you're going to end up with about 1 hour earlier. So if you see a constellation rise at 6 p.m. on one night, 1 week later, you're going to see it about 6:30. You're going to see that constellation rise. And 2 weeks later, you're going to see it rise about 7 p.m. So it comes up earlier and earlier and earlier that the constellations actually come up over the horizon. In 1 month, that amounts to 2 hours earlier for each individual constellation. And in 1 year, we're back to where we started. And again, this is due to, as we orbit the Earth, we see a slightly different view of everything every single day. All right. Another thing you're going to find on star charts are things that are called Messier objects. Okay, repeat after me. Messier. Messier. Now, this is named for a fellow named Charles Messier. The R, the last consonant, often in French, is not pronounced. He was a comet hunter back in the 1700s. The King of France gave him a lot of money and said, go out and find comets, because at that point in history, comets were considered prophets of doom, and if you saw a comet, it foretold that a king would fall, kingdoms would fall, wars would occur, plagues would happen. It was a bad thing. And so the King of France gave Messier a bunch of money and said, go look for comets. And so he did, year after year after year. And he found lots of comets, but he also kept finding fuzzy-wuzzy things that didn't move. Comets, one night to the next night to the next night, comets are going to be in different locations across the sky. But Messier found fuzzy-wuzzy things that didn't move from night to night. They stayed in one place relative to all of the other stars and the constellations. He didn't know what to do with all these fuzzy things. He did not have terribly good telescopes 250 years ago. And so he just cataloged them. He just put them in a pile. And today, this collection of about 100 fuzzy things that Messier found are referred to as Messier objects. These are some of the most beautiful, gorgeous, fabulous things to look at through telescopes. And this Messier catalog became a shorthand collection of names for these absolutely gorgeous things. This picture pictures all of the different Messier objects that are out there. Now, there are just over about 100 Messier objects. If you ever get your own telescope and want to look at things that are absolutely gorgeous, I highly recommend looking at these. Astronomers use the numbers Messier gave these objects in his catalog as shorthand names. For example, the Crab Nebula is known as M1. M2, this is M2. It happens to be a specific globular cluster. The Trifid Nebula is M20. And these are shorthand names. So maybe you've got a friend named Thaddeus, and instead of calling him Thaddeus, you call him Thad. Or you may call him T. Whatever works, it's a shorthand because we humans are basically pretty lazy. Now, Messier objects show up on star charts. This happens to be a star chart. Okay, take a moment, read the star chart closely. What constellation is this? What constellation is pictured here? Which one is it? Sagittarius. See these dotted lines? These dotted lines separate one constellation from another up in the night sky. So this happens to be the constellation Sagittarius. Sagittarius is located very close to the heart of the Milky Way galaxy. And because there's so much action, there's so many stars, there's so many things going on down there, that there are lots of Messier objects. You can see M16, M17, M25, M22. M22 is called the Sagittarius Cluster. M17 is the Horseshoe Nebula. Let's see, can we find it? There it is. M17 is the Horseshoe Nebula. M16 is the Eagle Nebula. That's located up here. M8 is the Lagoon Nebula, one of my favorites because it is so incredibly pretty. Again, located near that heart of the Milky Way galaxy. Star charts, besides giving us stars, apparent magnitude, constellations, Messier objects, also have a tendency to include the Milky Way galaxy. Now, we are out about 2/3 of the way out on one arm of the Milky Way galaxy, and so we are looking through the whole rest of the Milky Way. It's like you took a slice of the Milky Way, and if you and I are sitting here, we're looking through the rest of it. So what it appears in the night sky is it looks like this. This is the central, this is the arms of the Milky Way, and then there is a central bulge. I'm going to change colors on my pen because I couldn't even see that because I was working with purple. Okay, here's the central bulge of the galaxy, and then these are the other parts of the spiral arms. We're looking through that plane of the Milky Way. So where that big center portion of the Milky Way is located is also shown on star charts, and it's shown as darker areas. The center of the Milky Way is full of a lot of dust, lots and lots of dust, and you can't see through big clouds of dust. You've driven on a dirt road ever, you can't see through clouds of dust. Astronomers have the same problem. So these big areas here that are outlined in blue, this is the dustiest, most opaque center of the Milky Way galaxy. The bits that are a little bit lighter blue, these are the less dusty fragments and sections of the Milky Way galaxy. But the Milky Way is located on star charts, and it's usually this shaded area. Here's a pretty picture to just kind of put things into perspective. If you went to some place that was very, very dark, way out in the mountains, way out in the country, away from a lot of light pollution, you could see the arc of the Milky Way, the heart of the Milky Way. The bulge is located in and around the constellation Sagittarius, which is not a teapot, but a lot of people see a teapot. So people draw teapots for Sagittarius, but that doesn't make any sense at all. There are, so it goes through a variety of different things. Aquila, Cygnus, the summer triangle here contains of Aquila, Lyra, and Cygnus the swan. Cepheus, here he is in his dunce cap. Pegasus, here's the big square of Pegasus down here. Ophiuchus kind of looks sort of like a coffin in the sky. It's kind of big. And as I mentioned, the heart of the Milky Way is located towards Sagittarius, which is not a teapot, but it sure looks like one in the sky. All right, that will do for that section, and we'll come back and talk about measuring with angles later.